Video where today I'm going to show you how to set up this. This is a IoT RGB controller using a Raspberry Pi Zero-W. You can use any Raspberry Pi for this, but that is what it is. To do something a bit differently today, I've actually got a link in the description to an article I've written with all of the commands you can copy and paste, but the video has a little bit more explanation of how things work. So let's get started. First things first is we are going to have to image our Raspberry Pi. So we are going to select a device that we're using. So I am using the Raspberry Pi Zero, and I'm using the W edition. We're going to choose an OS. Any of these work. You can choose the full OS if you want a desktop, or you can use the light version. Let's just go with the full OS. Choose our storage device. So there we are, generic mass storage, and we're going to press next. Now to edit the settings. So what you want to do is you want to set your username and password so you can SSH into this. I'm going to be using the username lights in this. You can use any username you want, as long as you understand that later on in the video when I'm setting up the auto boot script that you need to use your username instead of whatever I've set. Other than that, we're going to then go to services. We are going to enable SSH, use password authorization, and press save. We are then going to press yes. You sure you want to wipe all the data on your SD card? I'm going to press yes. And now we press next. Yes. Yes. You may have to authorize it if you're running this as administrator. And this can take anywhere from about 5 to 20 minutes, depending on the image you've chosen. So I will see you all in a minute. Okay, so once that takes a while, you plug it into your Raspberry Pi and let it connect to the internet. I use a network scanner app to find the IP address, and it took about 20-ish minutes for it to finally show up. First time booting a Raspberry Pi always takes a while. So we can just SSH into this now. So I believe we called our account lights. There we go. So that's the command. If you get an error, you might have to stick a sudo in front of it. If you're on Windows, sometimes it might just ask you if you want to press yes, and there we go. So the next thing we're going to do is we are going to update and upgrade the packages. Now, this command can take anywhere from a few seconds to half an hour to run, so I am going to leave this be again. I promise you, from here onwards it will get faster, but this command, yeah, will take probably another good 25, half an hour. So I'll see you in a bit. Okay, so welcome back after that. It took me a little bit of time and my laptop ended up closing the connection with my Raspberry Pi, so I just had to reconnect to it. I think it ended up taking me 15 minutes to do the update completely. So the next thing we're going to want to do is we're going to want to disable the GPIO 18 pin. And this is so that when our Pi has audio going off it doesn't change our lights. You might end up using a different GPIO pin, but it's just a good practice to disable it. So we are going to sudo nano boot firmware config.txt. We will then scroll down to where we have this DT parameter audio, and we are going to set that to be off. And then we are going to exit that and save. So there we go. The next thing we're going to want to do is do a reboot after all of this. So we are just going to do sudo reboot. So this will take a little bit of time. It will kick us out of the Pi, but oh well. So the next couple of steps will be installing the packages. So we're installing the Python packages, and then doing the wiring, and then cloning our repo, and then it will be working. After that, we can do some other cool little things to make it turn on at boot. So it may take a couple of seconds to let the Pi turn back on. There, at least with me, we're using an old Raspberry Pi Zero 1, it can take a couple of minutes, so I will cut back to when that is on. Okay, so now we have come back after the reboot. We want to install two packages. So both of the links to these packages or the commands will be in the form in the description, so just copy and paste them. We want to install two Python libraries, and then we are going to want to add the flag -- break system packages. packages. There we go. See if I got that spelled right first try. So, why that might sound a bit scary as a flag to include, it is basically going to install it globally. I've already installed these libraries, so it was a bit quicker. It will install it globally. If you're using your Raspberry Pi to run other Python projects at the same time and you know there'll be a conflict, feel free to set up a virtual environment. It will still work. That was just a bit too much for this video, so we are just going to install all of our packages globally. The next command we are going to use is sudo. Let me copy and paste that over. I've already written these. All of these will be in the description. But we are going to use sudo python and then pip reinstall, force reinstall this Blinker package. Again, we are going to add break system packages. I butchered that. Packages, there we go. Why they install, it shouldn't take too long, but yeah, the reason we are installing this globally is out of ease. We're running a Raspberry Pi Zero, is unlikely to conflict with anything else, but I know a few other Python packages will conflict with other Python projects. So if you're planning to run other stuff on here, take a couple of minutes and look at virtual environments. But for us, it should be fine. And why they're installed in the background, I'm going to show you the next step, which is the next step is wiring. So we are going to want to wire together this. This is what you want to do. You want to do it with your Pi Zero. You want to collect your ground to the 3rd pin on the right, and you want to connect data to the 6th pin on the right. You will then want to quickly set up your power and your ground to an external power supply. Just make sure that whatever lights you buy and the power supplier are within range of the same volts and amps. If you do what I did, which is strip apart an old phone charger by cutting the head off and sticking them on together, I would recommend investing some heat shrink to stop any connection shorting. I have lost a fair amount of hardware before by wire shorting and killing off components. So there you go, that is my bit of advice. The circuit diagram, if you want another look at that, is back over on the website. Now everything's installed, we are just going to copy over the code from the repo in the description. Open up the folder, and then this should, you find, will work fine. So we'll give it a quick test by running, ls. We'll run sudo python app.py, and you should find that it will open up the website fine. There we go. So we will open up that, and as you can see, you have your color control here, and if you've done your wiring correct, they should work. Fine. If this doesn't work, I would check that you have done your wiring correctly. So that is the project set up. But we can do a few other small changes here to just improve quality of life. So next we're going to get this to start up on boot, and we're going to do that by creating a new system MD service. So we're going to want to run this command, which will create a new system MD service called LED apps. This will also be in the article. So paste that in. Next we are going to want to copy and paste in my config file, which I've already prepared for you and also put in that article. What you are going to want to do though is where I've got it here in working directory lights and the directory above where it is lights, you need to make sure that is whatever username you use when setting up your Raspberry Pi. I set it up, the account, when imaging my Pi with the account lights. If you use something else, you need to change it. So we will break Control X and Y and enter to save that. There we go. Next we are going to want to start this system. So we will run these 4 commands in order. The first system reloads the daemon. We are then going to enable our LED system and we are going to start it. So this might take just a couple more seconds to run. Everything always seems to. So we will give this a few seconds, and then we will check the status of this system. And as you can see, it should say active running, which means this is working fine. So that will mean it will boot up at start. We can do one final change, which will make this even easier as a project to use. Which, instead of having to find our Raspberry Pi's IP address, we can set up a local host name. The local host name you can put in your browser of choice, and it will go straight to your control panel without you having to scan the network for your IP each day. So we're going to run sudo rasconfig. We'll go into system options, scroll down to host name, press OK, and put something that you can remember. No spaces, no capitals. So we might call this Smart Lights Room. So there you go, and we can press OK. When you finish, it will make you reboot, so press yes, and I will be back in a second when it has restarted and I have reconnected to it. So as you can see, I've managed to reconnect to my Raspberry Pi, so it is alive. And if we have done everything right, you can type in our URL or the hostname that you just chose. So I've chosen smartlightsroom.local, press enter, and the control panel opens up. Now you can book that, add a shortcut to your desktop, and everything's working. So I hope you learned something new, I hope you enjoyed this, and I hope you will subscribe, and I'll see you in the next one. Bye!